All right, let's start talking our way through this bell work. I want to start off with the description of the transformation. We're going to start off with words. There are 3 different things happening in this equation. So I want you to tell me one thing that you know would happen to the graph to change it, and tell me who's doing it, A, H, or K. Yes, Mia?
Shift right, and it's because of H.
Because of H. We're going to shift to the right. Yes. What we see right here is the opposite of what's actually going to happen. Our H is a positive 1, and that is going to shift it right. So we would go to the right 1. All right, we got 2 more pieces. Somebody else give me another one. Alex.
It will reflect over the x-axis
Because of A, yes. Our A value is right here. It is a negative 1, and that's going to make it reflect over the x-axis. All right, I've got one more piece. Who wants to volunteer for the last piece? What else is going to happen? It's not a vertical compression. Alicia. It's going to go up 2, and who's doing that?
2.
Yes, that 2 on the end, and who is that? Is that A, H, or K?
K.
That's K. Good question about the vertical compression. I do want to take a moment to talk about that and address that, because this is a really important time to discuss that. We've got that negative out in front, and a lot of times we think, oh, if it's smaller than 1, it's going to compress. And that's true if I'm only talking about the actual value itself, not looking at a positive or a negative part. If it is a positive number, it's going to open up. If it's a negative number, it's going to open down. But then after I know whether it's opening up or opening down, I don't care about the positive or negative anymore. Then I shift my attention to just what is the value there. In this case, once I get past the negative part, I'm left with just a 1, right? Will a 1 stretch anything? If I multiply things by 1, will they get bigger? If I divide things by 1, will they get smaller? No. That's why there's no stretch or compression there. We look at the positive or negative part first, and then we go look at the actual value. That was a great question. Thank you so much. Or comment, I guess it was. What is the vertex going to be for this parabola? Yep. 1, 2. Because first we have our H, and then we have our K. Absolutely correct. Give me the axis of symmetry, and I want the whole thing, so be careful not to leave anything out. Alicia. X equals 1, yes. This will always, 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 and forever be x equals whatever our h value is. Let's do domain right now, but then I want to hold off on doing the range until we can look at the graph, because I want to make sure that we're understanding where this is coming from. My domain I can do ahead of time, because for all my parabolas, the domain is exactly the same. Jimmy, do you by any chance remember what that domain would be?
Negative infinity, infinity.
Yes, negative infinity to positive infinity. This is the same exact thing as saying all real numbers. We're describing, starting with the smallest and ending with the biggest, all the possible things we're allowed to use for x. So we're saying the smallest thing we can use is negative forever and ever and ever. And the biggest thing we can use is positive forever and ever and ever. There's no restrictions on it. It's all real numbers. All right, let's do our graph next, and then we will talk about the range. Did you have a question, sir?
Is it always like this, that, for domain?
For the domain. For all of our parabolas, yes. Most of the functions that we study this semester, that will be our domain. When it changes, I'll make sure to make a big production out of it. Yes. Yes, ma'am.
Is it only for the parabola, or like because when you graph like you gotta put like your y and x output,
Mm-hmm.
like on the domain and your range, like is it always like that?
Yes. So I know back in like Algebra 1, when they have you do domain and range, if you're looking at a specific situation, sometimes you're going to have very specific values there. But when we start talking about function rules, then it's going to look like this. So yeah, that's another great question there. You are never going to have to list out values for me for your domain and range. We're going to be looking at interval notation there. All right, I'm going to make a table now. We're going to do our parent function first. So I get my x and y on there. Remember, the parent function for a parabola is y equals x squared. We get to choose the x's that we're going to use. I have some favorites because they're easy to work with. What are my 5 favorite x's, Mia?
-2, -1, 0, 1, and 2.
Yes, -2, -1, 0, 1, and 2. Shows me everything I need to know about the function without the numbers getting too overwhelming. Shows me what happens when it's negative, what happens when it's right at 0, what happens when it's positive. What are we going to do to each of those inputs, each of those x values, to find our y's, Alicia? We're going to square them, yes. The parent rule says we take our x's and we square them. We multiply them by themselves. So altogether, tell me straight down the y column, what are the 5 outputs we're going to get? Soraya.
4, 1, 0, 1,
4, 1, 0, 1, 4. Why is it not -4, -1, 0, 1, 4? Mia.
Because negative times negative is a positive.
Negative times a negative is a positive. So anytime we square something, it's going to be a positive output. I'm going to go put this on my graph, even though I know they didn't ask me for it. I want to make sure that what I described in words is what we actually see happening on our graph. Remember, this should have a U shape to it, not a V shape. All right, so there's my parent. Now we're going to get the points for our transformed function. So I need to get my new x and my new y based on my transformation. What do I need to do to get the new x's? Soraya.
You add plus h.
Yes.
1.
We're going to add h to each of these. In this case, that's a +1, so I'm adding 1 to each piece. That will take my graph and shift it to the right one. So I end up with -1, 0, 1, 2, and 3. How do I get my new y's? I still have 2 pieces. We're going to multiply by which piece? -1. That a value out in front, do you see how that's smashed next to the parentheses? That means it's being multiplied, and multiplication comes before addition or subtraction. So I'm going to multiply everybody by -1. Yes. And then we're going to add 2 because it's a +2 there, and that will shift it up 2. We always multiply first before we add or subtract. So there's another math teacher here that uses a little acronym to remember the order for the y's. And they say that transformations make her want to yak. The y and then a and then k. Transformations make her want to yak. So if you're having trouble remembering the order, that might help. When I multiply these y values by -1, what happens to them? What is 4 times -1? -4. It didn't get bigger or smaller, but it did become negative. That's why we wouldn't have a stretch or a compression, because the 4 stayed the same, but now we have a negative sign on the beginning. That's going to flip it over. So I have -4 plus 2. What's -4 plus 2? -2. And then I have -1 plus 2. 1. 0 plus 2. 2. And then what happens after that point? starts to repeat. My y values, my original outputs repeated, and so my transformed y's will also repeat. All right, so here's what I'm going to graph for my transformed function. -1, -2, 0, 1, 1, 2, 2, 1, and 3, -2. Before I sketch this in, what do you notice about those points? Yeah, it's pointing down. I see my vertex is up at the top, which means my vertex is a maximum or a minimum? Yeah, my vertex is up at the top, and so it is a maximum. That is a highest point. Let's check to see if this parabola did what we said in words it was going to do. We said it was going to be to the right of the parent function. Is this red parabola to the right of the parent function? Yeah. Compared to the blue one, it has been shifted over on the right side. We said it was going to reflect over the x-axis. Is that true? Yes, it opens down. That would be a reflection. And then we said it was going to be up 2. It's kind of hard to tell because of these arrows, so I'm going to focus just on the vertex. Is this vertex higher than my parent vertex? Yes. If the vertex is higher, the whole thing has moved up. If the vertex is lower, the whole thing has moved down. All right, let's go do the range, and then we'll wrap up the bell work. So when we talk about our range, I always want the smallest possible output, the smallest possible y value first. And then second, we put the largest possible y value. Range is always talking about y's, so I'm only looking up and down. I don't care about left and right at all for this. What do you notice on the bottom part of this parabola? The red one. Yeah, there's arrows down here. What does that mean if I'm trying to find the lowest point? -infinity, because this goes down forever. So there is no lowest point, so I need to describe this as -infinity. But then I want the maximum, the highest point. Does this parabola have a highest point? 2. That came from our k value. The vertex, the y part of the vertex, the k value will always be part of your range for these. It'll either be the lowest if it's a minimum, or it'll be the highest if it's a maximum. But it's going to go in one of those two spots on my range, and it's always going to be k. You with me, Jimmy? I know, it's early still. I use a square bracket because I actually have a dot on my graph there. I can't put a square bracket around infinity because no matter how big of a graph I give you, you can't ever go put a point on infinity. That's why we use a parenthesis there. Do you guys have any questions for me? Anything at all about the bell work? All right. If you don't have any questions for me, then I want you to open up your books. Hopefully your books are already open, but we're going to flip forward a couple of pages to page 62. Page 62 in your books. So up until this point in Unit 2, I've been giving you equations, and I've been asking you questions about the graphs. And we've gone from just identifying things about the graph to making the full graph. Today, we're going to start working on how can I take that process and go backwards with it? How can I look at a picture of a graph and come up with the equation of the graph? That's what we're going to learn how to do today. All right, so on this first one, this is not meant to be a trick question at all. What is my vertex? Yep, my vertex is 1 and 4.9 from right here. Not a trick question. So what do you know the h value would have to be then? 1. And what would the k value be? 4.9. If I was going to write an equation of this in vertex form, in case you guys don't remember, y equals a times x minus h squared plus k. That's my vertex form. Are there any of the pieces for this parabola right here that I know and I could substitute in? I can put in h, I can put in k. Do I know what the a value is? No. For right now, I'm just going to leave it as an a because I don't know what it is. I've got my parentheses with x in there, and I know it's going to be squared. Help me fill in these pieces. We know that h is 1. What am I going to see here? A negative. Because remember, inside the equation, it's the opposite. What would I see on the end?
4.9
Just 4.9 like this?
plus
Plus 4.9, because it's a positive, yes. So far, so good? You guys understand what I see on the graph and where I put it in the equation? Cool. We're going to figure out what this a value is, and we're going to finish writing this one out, but we're going to move down to the next question to do it. All right, so I want to look down below. Same exact parabola down here. So I'm going to go ahead and mark the vertex. Our vertex is 1 and 4.9. But then they ask me about the zeros of the function. What's a synonym for zeros? What do they mean? X-intercepts, and I heard roots. And solutions, yes. Anytime they give us one of these words, I'm going to ask you guys for the synonyms, because it's really, really important that these ideas become absolutely enmeshed in our minds. So I'm looking at this graph, and I'm trying to find the x-intercepts. Well, I see my x-axis. That's right here. The x-intercepts are where my parabola crosses that x-axis. So right here and right here. These are zeros, roots. I guess that one wouldn't be plural. It's just a single zero. I want to write those as ordered pairs. I'm going to have 2 ordered pairs because there's 2 points. Look at the one on the left. What would the ordered pair be for the one that I've circled on the left side of this parabola? 0, 0. And now I want to write the ordered pair for the other one. Remember, when I write an ordered pair, the x part, the left-right part of the ordered pair comes first, and the y part comes second. 2, 0. Beautiful. So now I want to take that idea, and I want to write possible factors. We normally use our factors to find our roots, to find our solutions. I'm going to write down factored form in case you don't remember it. That's the one that looks like this. And when I have it in this form, we always take our factors and we set them equal to 0, and that's how we find our roots. Factors are always equal to 0. If it's equal to something else, it's not a factor. Well, I know the x parts of both of these ordered pairs up here. I have this, that's x, and I have this, that's x. So x is 0, and x is 2. Are you guys comfortable with where I got those from? Tell me if you're not.
Did you use 0 and 2 and press R?
Yes. These are my r's. These aren't my factors yet, but I'm looking at the graph where it crossed the x-axis at. So I've got x equals 0 and x equals 2. Factors have to be equal to 0. Are either one of these equal to 0? First one. This one is equal to 0. And so that means that this right here is a factor. Looking at this one over here, x equals 2, is that equal to 0? What would I need to do to it if I wanted it to be equal to 0? Subtract 2 from both sides. So that would cancel out over here. What would I have on the left? Almost. Negative 2x would mean multiplying. Negative 2 plus x, or I could write it as x minus 2. Same idea. X minus 2 equals, what would I have on the right? 0. Is it equal to 0 now? Yes. Equal to 0, which means this right here is a factor. Factors are what make up the equation. Roots are where I see it on the graph, but factors make up the equation. All right. I notice that this parabola opens downward. What does that tell me about the equation when I think about AH and K? The A is negative. A must be negative. Question D says, if the vertical stretch is 5, what is the algebraic representation of the function? I just want to focus on this vertical stretch being 5 for a minute. Whose job is that, AH or K? A. So it's got a vertical stretch of 5, that's A's job, but it also opens down, so A has to be negative. Which means my A value is what here? Negative 5. Negative because of this, 5 because of this. All right. We are all ready to write our equations. Look at the one that we wrote up above. We had y equals A times x, and then we had minus 1 squared plus 4.9, right? This is the exact same parabola, and they just told me what I should use for A here. What should I put in that spot where the A is? Negative 5. So there's one possible equation. We're going to write a factored form for this exact same parabola. Y equals, here's my form for factored form. It starts with A. So what should I use for A? Negative 5. And then we've got our two factors. Factors are equal to 0. What are the two things over here that I have that are equal to 0? X minus 2 and x. So I have x and I have x minus 2. If you want to put this one x inside parentheses, because we always put factors inside parentheses, that is totally fine. So that would be another representation of the exact same parabola. The first one is vertex form. This one tells me where to find the vertex on the graph. The second one is factored form. This one shows me where the x-intercepts are. Are you guys okay with how we came up with those? They had to tell us what A was. We'll keep practicing. We'll keep practicing. Go ahead and flip the page to 63 for me. What did I just call this form again? Factored form. That is our factored form. We're going to identify the zeros of the function. Give me those synonyms one more time. I heard roots, I heard x-intercepts, and solutions, yes. In order to find those, what do I need to do with each of my factors? Equal to 0. Factors always get set equal to 0. So what would I need to do to find the roots, the x-intercepts? Minus 5 on both sides. So I get that x equals -5. They want me to write this as an ordered pair. So what would this ordered pair look like? -5 and then 0, yes. What do I do to find the other x-intercept? +1 on both sides. So I have x equals 1. That ordered pair would be what? 1, 0. I want you guys to do part B on your own. That A value of the -3 out in front won't affect your roots at all. You can just ignore it and then do exactly what we did on part A. So what would these ordered pairs be? 4, 0, and -5, 0. Awesome. Absolutely correct. What do you guys notice that's a little bit different about part C? There's only one, right? But it's being squared. What does something being squared mean? Multiply it by itself, so it means we really have it twice, right? So this idea right here means that I have x minus 6, and I have another x minus 6. When I take these and set them equal to 0, they're going to give me the same answers, right? So what does that mean I would see on my graph then? Would I see no roots, 2 roots, or 1 root? 1 root. And it's going to be at 6 on the x-axis. So 6, 0 would be my only root. It is the vertex. That's the only way that it can happen that we have just 1 root, is when that 1 root is my vertex. All right. We're going to hop down to number 4. And we are going to practice starting in vertex form and then converting that into general form. General form for a quadratic function, that's my ABC form. Y equals ax squared plus bx plus c. If they give me vertex form, and I'm supposed to change it into general form, we will follow order of operations. PEMDAS. Now, when I'm doing order of operations with something that is in vertex form, I have parentheses, but I can't simplify it at all. So this is going to be our process every single time. We are going to start with the exponents. Then we will multiply by our a value. Exponents come before multiplication, but multiplication comes before addition and subtraction. So exponents first, then we multiply by a, and last we will add k. So we're going to practice that. We'll get more practice with this tomorrow, but we're going to practice it through the first time right now. I see an exponent here. It's this little 2. What is that exponent on? On the parentheses. So this right here, when I say I need to deal with the exponents first, this is what I'm looking at first. What does it mean for something to be squared? Multiply it by itself. So I have x plus 2 that's being multiplied to another x plus 2. Help me out for just a second. If this first thing right here wasn't an x plus 2, let's pretend it was just a 2. What would you do with that? Not substitute. How would you deal with this and then this inside parentheses? Distribute. We would use distributive property, right? We're going to do the exact same thing here, but I've got 2 pieces. So I have to distribute the x to both pieces, and I have to distribute the 2 to both pieces. We call this double distribution. We are going to double distribute. So first I take the x and I multiply it to each piece. What is x times x? X squared. What is x times 2? 2x. So I have x squared plus 2x when I do that distribution. And then I'm going to take the 2 and distribute it to both pieces. So what's 2 times x? 2x. And 2 times 2? 4. Are there any like terms that I can combine together? 2x and 2x can be combined. The x squared is not a like term, so you're correct there. We cannot combine that. It does have an x, but it doesn't have the squared, and it has to match the variable and the power to be a like term. All right, let's talk about where that goes now. That was just my first step, my exponent step. If I rewrite my original equation, but leaving out the piece that I was working on. Yep. All of this right here is what goes in my parentheses. X squared plus 4x plus 4, and then I have the minus 6 on the end. Are you guys okay with what I've done so far? This part over here is the hardest piece of this. If you can get this part done, the rest of it's a piece of cake. Alicia, I saw you making a motion with your hand as far as what I want to do next. Do you have a word for what you were showing me with your hand? Distribute, yes, there we go. I'm going to take that a value and we are going to distribute it. But that a value from back here, it's only on the parentheses, right? So I only multiply these pieces by a, not that minus 6 on the end. So I'm going to take this 2. It gets distributed. So I would have y equals 2x squared plus 8x plus 8. I bring down this minus 6 on the end. Now I'm going to add my k, or in this case we're going to subtract because k was negative. I can combine these two terms together. And what would happen when I combine those?
2.
Yes, I get y equals 2x squared plus 8x plus 2. Is that in ABC form like this?
Yes.
Yes. Tomorrow we will pick up with those graphs at the bottom of the page. We are going to be able to write all 3 forms looking at those graphs there. Your next homework assignment is not due for me until Tuesday. We're going to keep talking about this tomorrow, and then you guys have the long weekend. So you're welcome to open it up and start looking at it now. But it is not due until Tuesday, and we have not talked about all the pieces yet. All right?